Hello and welcome in to the video for lesson 6. As you see on the schedule, we have a few items listed. So we have SOHCAHTOA, we have area of a triangle, we have inverse functions. So it looks like, oh, this might be pretty quick, but this will likely, as you can tell from the timestamp, be one of the longer videos. So I'll kind of let you know when we're moving from one topic to the next. And that way, if you want to hit pause, take a quick break, take a long break, and then come back and finish it, you're more than welcome to do so. But I wanted to keep it as one video. Again, this is the content video for Precalculus 2. And so I just wanted to keep it as one video so you have it all right there, and then you can, go back as you need to. So let me share the document camera here for you guys. All right, so grab some extra paper here. So within math, there's things that people seem to always know. They know Pythagorean theorem, they know quadratic formula. If you've had any sort of trigonometry, you probably know SOHCAHTOA. And so SOHCAHTOA is the acronym we use for our trig ratios. Now, the important thing here is that SOHCAHTOA can only be used for a right triangle, meaning one of the angles is a right angle. So two things. One, if it's not a right triangle, you can't use SOHCAHTOA. Instead, you're going to have to use either law of sines, law of cosines, the next two lessons that we'll be talking about. The good thing, though, is that if you are given a problem from now until the end of the semester, and it says in a right triangle, ... then that is your key that, hey, this is probably a SOHCAHTOA problem. So that's a good thing. When you see that word right triangle or those words right triangle, that's your signal. Use SOHCAHTOA or try to do SOHCAHTOA. So if I have a right triangle, so one of the angles is a right angle, and let's say that this angle down here is theta. Now, theta could also be up here. I'll draw that triangle too, because sometimes that causes a little confusion. So the side that is opposite the right angle is always what's called the hypotenuse. And then wherever theta is, the other side, not the hypotenuse, but the side right next to it, is what's known as the adjacent. Which makes sense, right? Adjacent, right next to it, that's that one. And then the side that is across from the theta, or it's what? It's opposite theta. So these three sides have this different notation. Adjacent, the side that's right next to theta, opposite, the side that's opposite of theta, and hypotenuse, the side that's opposite the right angle. And so the way that this triangle is drawn, adjacent is on the bottom, opposite's on the side. That's only because theta is down here. Because if theta was at the top here, well, this is still the hypotenuse. But now this side is right next to theta, so that's the adjacent. And the angle down here is, the side down here is across from it, so that is the opposite. So you have to pay attention to where is the theta. And that's what determines adjacent or opposite. It's not like, oh, I remember in the video, the adjacent was on the bottom. No, the adjacent's only on the bottom here because theta is right there. So be careful with that. Now, once we have this adjacent, opposite, hypotenuse, that's where this idea of SOHCAHTOA comes in. Because if I have sine of theta, this is equal to, well, S for sine O for opposite, H for hypotenuse. So it's opposite over hypotenuse. 2, cosine of theta. Cosine, A for adjacent, H for hypotenuse. So cosine is adjacent over hypotenuse. And tangent of theta, OA, opposite adjacent, so it's opposite over adjacent. And so as long as you know SOHCAHTOA, sine, cosine, tangent, then we also know what? Cosecant, secant, cotangent, because they're just the reciprocals of this, right? So cosecant of theta is hypotenuse over opposite. Secant of theta is hypotenuse over adjacent. And cotangent of theta is adjacent over opposite. But you don't really need to know these, or at least what the setup is, because as long as you know SOHCAHTOA, then you can figure out the rest from that. So let's say, well, let's look at like a quick example here. So let's say I have a right triangle. Put my theta down here, and let's do I don't know. Let's do this. 3, 4, 5. One side is 3, the other side is 4. The hypotenuse is 5. So from theta, the 4 is the opposite. The 3 is the adjacent. And of course, the 5 is opposite the right angle, so that's hypotenuse. So if I want to know sine of theta, well, by SOHCAHTOA, it's opposite over hypotenuse, 4 over 5. If I want to know cosine of theta, that's adjacent over hypotenuse, so 3 over 5. And tangent of theta is opposite over adjacent, so 4 over 3. Now, in this problem here, I gave you all the sides of the triangle, 3, 4, and 5. But let's assume that you're given a problem and you have 3 and 4, and you don't know what the hypotenuse is. Well, one of the things I mentioned right at the start is one of the formula everybody always seems to know is what? The Pythagorean theorem. So we had the Pythagorean identities earlier in the semester. Pythagorean theorem says that a squared plus b squared is c squared, where a and b are the legs and c is the hypotenuse. So do not get that mixed up. If, for example, you were given like 3 and x and 5, well, it's not 3 squared plus 5 squared because those are the two numbers I was given. No, it's the legs go here equal the hypotenuse squared. So be sure when you're calculating those, you're plugging them into the right variable for the formula. All right, the next concept we're going to look at here is the idea of angle of elevation. And angle of depression. So let's say we have some guy and he's standing on top of a building. So straight out from him, this is called the horizon. If where his line of sight is straight out, that's the horizon. Let's say he sees a plane up top here. This angle in here is what's called the angle of elevation. Of course, elevating, looking up. So angle of elevation. And then maybe he sees his friend down here on the street. So the angle down to this guy is angle of depression. So depression down, so the angle going down. So angle of depression versus angle of depression, elevation versus angle of depression. Now we are going to have some problems that I'll talk about here in a second. I call them the plane over the straight road problems. That's how they can be worded as a word problem, but they don't always have to be a word problem. It doesn't always have to be a plane. It could be some other object, a hot air balloon, or I don't know, a guy standing on a building or something. And so in that situation, it's important to note because a mistake that people often make, so say that there's the pilots up in the plane looking down at the guy in the building. And I say, okay, angle of depression is 30 degrees. So from the plane, its horizon line is here. So its angle of depression down to the guy, so I'm going to call it AOD, angle of depression. His angle of depression goes here, not down underneath. And so when we have something like that, so we can have the following. So angle of depression down to an object is equal to the angle of elevation up to the object. So for example, if a plane is looking down at the guy on the roof, the angle of depression down from the plane is the same as the angle of elevation from the guy up to the plane. So these two angles, highlighter here, in this situation, these two angles would be equal to each other. The angle of depression down from the plane to the person is the same as the angle of elevation from the person up to the plane. Now, as I said, there's a common type of problem that you'll have in this class. It usually appears on a test. It sometimes appears on the final. So I'm going to show you conceptually how we do these problems, and then I'm going to give you a formula that if you use this formula, it takes all the trig work out of it, really. Takes all the guesswork out of it. So we have a type of problem where it's like a plane is flying over a straight road. And it sees two objects. So the first situation is where the objects are on opposite sides of the plane. So for example, maybe the plane's flying and it sees a car down here and a car down here. And the height of this plane is h. And the question says, how far apart are these cars? And so what we would have to do normally, so this is forming a right triangle. Oh, right triangle, that's SOHCAHTOA. So we would calculate x, we would calculate y, and then we would add them together. So when they're on opposite sides, we add. And so we're given the angle of depression from the plane. And so we just said what? The angle of depression down is the same as the angle of depression up. So let's call it theta small and theta big. So whatever number is smaller, whatever number is bigger, it doesn't matter. It's not like it's like one car has to be on the one side or the other. So that's opposite sides. And again, we would do tangent because opposite over adjacent. So tangent of theta s is h over x. And then we do all the work to figure out what's x. And then we do the same thing for the big theta, h over y, solve for y. That gives us y, then add the two together. If there's a plane flying over the road and it sees two objects on the same side, well, then the picture I have is something like this. So here's our plane up here flying at the height of h. And we see two cars and we want to know again, all right, what's the distance between these two cars? And so my distance up here was this guy, this long line. Well, in this situation, so this is going to be my theta small, and this will be the bigger theta. So obviously, the closer I get to the plane, the bigger the angle is looking up, right? Out here, the angle might be 10 degrees up to the plane, but if I'm right under the plane, it might be like 80 degrees to look up at the plane. And so what we would have to do mathematically is figure out this guy, the long side of the triangle, figure out this part, y, and then subtract them. The big minus the little gives me the distance between, which is what I'm looking for. And so in that situation, we need to subtract those values. And so again, it's going to be a tangent problem. Tangent of theta s is h over x, solve for x. Tangent of theta b is h over y, solve for y, subtract them. I'm going to save you a lot of time and trouble and calculations and struggling with word problems, and I'm going to give you the following formula. It says the following: the distance between these points, either opposite side or same side, is h, the height, over tangent theta small. So if this angle is 10 and this angle is 80, this is 10, tangent of theta 10. And then it's either plus or minus. Plus if it's opposite sides, minus if they're on the same side. And then my second term is h over tangent theta big. And that's it. If you have this formula, so write this on your cheat sheet, write this in your notes. When you have a problem like this, a quote unquote plane over the straight road, you have either of these two pictures, you can use this formula. And you can also use it to find like the height. So let's say we're trying to find the height, but we're given the distance between. Well, then we just have to manipulate this equation to be h equals something and then plug in the values then. But this formula is like gold. You definitely want to have that for your exams, memorized for the final in case it shows up on the final. If you guys want to see how this is derived, it's something I can do in class. It's something I can do in office hours. If you're one of those people that are like, wait, how do they derive the quadratic formula? Come to class, come to office hours. How do you derive this distance formula? Come to office hours or ask me in class and then I can show you. But that's the formula you're going to want to use. All right, next, we're going to be talking about area of a triangle. So we are going in this class, in Precalculus 2, we are going to have two different formulas for area of a triangle. None of them are ever going to be area equals 1/2 base times height. That's geometry. This is trigonometry. If you find yourself trying to use that formula on any problems, be it homework, exams, whatever, you're in big trouble because it's not going to work because you don't have the information you need. The first one that we're going to learn is this one. The next one we'll learn when we talk about law of cosines. But for now, we have the following formula. The area A of a triangle with sides A and B and included angle theta. So what included means is it's between A and B. So we need that angle that's between the two sides A and B. So once we have those two sides in the included angle, we have the following. Area is equal to 1/2 AB times the sine of theta. And again, we can go through the derivation in this in class or something if you wanted, but that's the formula. Theta does not have to be in radians or does not have to be in degrees. It could be either. You're just taking sine of that value. So if you're told that the angle is whatever, 50 degrees, well, it's degrees. So make sure when you punch this on your calculator is what? In degree mode. And in the example video, we will go through the example of finding area of a triangle with these included the sides and included angle. And then finally, so if you're like, okay, this is information overload, I need to like take a break for a second, go ahead, hit pause. I'll be here when you come back, or if not, reload the video if it shuts down or something. Because now we're going to talk about inverse trig functions and right triangles. Oh, right triangles, that means what? SOHCAHTOA. Yes, we're going to use that idea of SOHCAHTOA. So recall back to our inverse stuff. If I have something like sine inverse of x is equal to some value y, this is the same thing as saying that sine of y is equal to x. And it works for cosine too, right? Cosine inverse cosine, tangent inverse tangent. And so up until this point, we were given the value of theta, and we were trying to find the missing sides using SOHCAHTOA in a right triangle. But now let's say that we want to find theta and not find the missing side. Right triangle, oops, SOHCAHTOA must be. Let's put our theta down here. Let's put 10 over here and let's put 50 over here. So if I want to find theta, it's a right triangle, so I should be able to use SOHCAHTOA. And so then the question I need to ask here is, if I'm going to use SOHCAHTOA, which trig function am I using? Well, the 10 is what? The 10 is the opposite, and the 50 is the hypotenuse. So which trig function uses opposite and hypotenuse? It's sine, right? So I have sine of theta is opposite over hypotenuse. And so that means I can set up an equation. In this case, sine of theta is opposite 10 over hypotenuse 50. And now using our inverse functions, if sine of some value is equal to x, that means sine inverse of x is equal to y. So using that here means if I take essentially sine inverse of both sides, just like if I'm taking square root of both sides, I'm taking the inverse function. That gives me theta on the left side because these guys cancel each other out. And I get sine inverse of 10 over 50. And now this is where you're going to use your calculator, and you should see on there a little button or a little function where you can get the sine inverse. So you're going to do 10 divided by 50, hit your sine inverse button, and that should give you that theta is approximately 11.5 degrees. And again, because we're talking about degrees, we're in degree mode on the calculator. So try that before, if you want to hit pause, just make sure that you can do your sine inverse of 10 over 50 and get 11.5. Make sure your calculator is working right. Now, let me find my red pen because we have a caution. On your calculator, when you hit sine, when you hit sine inverse, it gives you the degree in quadrant 1. However, if we look at our unit circle, so let's say I wanted to know and this goes back to, remember when we were talking like right half of the circle, top half of the circle? Well, now we don't know. We're just saying that sine inverse is 10 over 50. So it's technically could be two different angles. So when I'm doing like sine inverse of 10 over 50, it gives me, all right, about 11.5. But if I look at the unit circle, if I do pi over 6, what's sine of pi over 6? Well, that's 1/2. So if I did sine inverse of 1/2 on the calculator, well, I should, let me do degrees, 30 degrees. So sine of 30 degrees is 1/2. So if I put on my calculator sine inverse of 1/2, it's going to tell me 30. But the thing I need to be careful about is where else is sine equal to 1/2? It's also equal to 1/2 at 150. 150 degrees, or what? 180 minus 30. And so, especially for the next section, when we're doing our law of sines, we have to be aware of this. When we were and when we start doing trig equations, same thing. If we do sine inverse to find a value, we're not talking about right half, top half of the circle anymore. We're talking about the entire unit circle. So on the entire unit circle, sine inverse of 1/2 is 30, or 180 minus 30, which is 150. So be careful of that. So the caution when we're doing sine inverse gives you the degree in quadrant 1, but don't forget about quadrant 2, because that same value falls in quadrant 2 as well. Okay, next thing I want to talk about is something called Pythagorean triples. And these are just going to make your math a little bit easier. So you can always use Pythagorean theorem to find missing sides of a triangle. But Pythagorean triples are right triangles that have nice sides. So for example, 3, 4, 5. So if I do 3 squared plus 4 squared, that's equal to 5 squared. And you could also use any multiples of this. So if I double it all, 6, 8, 10. So that's another one. If I have 5, 12, 13, that's another Pythagorean triple. So if I have a triangle that has either 5 and 12, or 5 and 13, or 12 and 13, I don't really need to use Pythagorean theorem to find the missing side. I can just use the idea of the Pythagorean triple. I have another one, 8, 15, 17. And the last one we're going to talk about is 7, 24, 25. So these are the two that you're going to use more often than not 3, 4, 5, 5, 12, 13, but you do have these other ones as well. And then the last thing I want to look at here is our inverse problems. So let's say I have, so find the exact value of cosine of sine inverse of 3/5. So if I go back to one of my earlier lessons, it's like, oh, okay, sine inverse, that's the right half of the circle. So where on the right half of the circle is sine equal to 3/5? The answer is I have no idea. So it's like, all right, well, how am I going to do this then? We are going to use a process known as build a triangle. And we are going to use this 3 times this semester. So make sure you write this on your cheat sheet. Make sure you know absolutely how to do this. We're going to build a triangle. The first thing we're going to do is set the inverse only, and you will see in future lessons why I say inverse only part equal to theta to take, and then the trig function. So whichever inverse I have, if I have sine inverse, do sine. If I have cosine inverse, do cosine. If I have tangent inverse, do tangent. So take the trig function of both sides. Three, and the reason I call it build a triangle is because we are now going to build, I should call it build a right triangle. Using, oh, well, right triangle, it must be what? SOHCAHTOA. 4, find the missing side. And you can either use Pythagorean theorem, or if it's a Pythagorean triple, use the Pythagorean triples. 5, this is where everyone forgets to do it, so they kind of get stuck at this point. So don't forget step number 5, which is rewrite the original problem with theta instead of the inverse part. And then lastly, 6, solve using the triangle. So if I have this problem here, I'm going to take the inverse only part, which is sine inverse of 3/5, and set that equal to theta. Step 2, take the trig function, in this case sine, of both sides. So I get sine of theta. These guys cancel out as equal to 3/5. Now build a right triangle and use SOHCAHTOA. Sine is what? Opposite over hypotenuse. So opposite is 3, hypotenuse is 5. And then find the missing side. Well, this is one of our Pythagorean triples, 3, 4, 5. Or you could do Pythagorean theorem if you wanted, if you didn't remember the Pythagorean triple. All right, so we built the triangle, we found the missing side. Now rewrite this original problem, and instead of using this whole messy inverse thing, write theta. So what this problem is asking me is, what's cosine of theta? So go to my triangle that I just built, Cosine by SOHCAHTOA is what? Adjacent over hypotenuse. So the answer to this one would be 4/5. So that is how we do a problem like that. When we have a number with the inverse function that doesn't fall on our unit circle. And the last time, or the, not last time, but the other instance where we're going to build a triangle is when we have something that says the following. Write as an algebraic expression in X. When you see that wording, write as an algebraic expression in X, or we're going to get into a situation where we have write as an algebraic expression in X and Y. But that part, write as an algebraic expression, this has to scream at you, this is a build a triangle problem. And what you get might be something like cosine of sine inverse of X. So it's like, okay, where on the right side of the circle is sine equal to X? I don't know, that doesn't make any sense to me. No, it doesn't, because this is a build a triangle problem. So set this guy equal to theta. So we have theta is sine inverse of X. Take sine of both sides. So I have sine of theta, this cancels out, is equal to X, but I'm going to write it as X over 1. And we'll see why here in a second. Because when I build my right triangle, sine is opposite over hypotenuse. So opposite is X, hypotenuse is 1. And so now I want this missing side, let's just call it A. So we have what? A squared plus B, which is X squared, equals the hypotenuse, which is 1 squared. So subtract X squared from both sides. I get A squared is equal to 1 minus X squared. And to get A by itself, take the square root of everything. So A is equal to the square root of 1 minus X squared. Now we do what? Now we rewrite the problem using theta. So really, again, this thing is asking me what's cosine of theta. So I go to the triangle, cosine is adjacent, hypotenuse is 1. So this is just simply 1 minus, sorry, square root of 1 minus X squared. So that's the other instance that you're going to use build the triangle up to this point. And then again, we'll use it twice more during the semester. And when we get there, you'll know because it says write as an algebraic expression in X. All right, so that is it for the content video for lesson 6. I know it was a bit longer. Again, I usually don't like to go this long, but this stuff kind of all ties together. That's why I wanted to combine it into one video. So come on back and we will look at a bunch of examples, a bunch for all of this stuff that we just talked about.